Thank you, Sharmaji. It's been an honor to be able to speak here. Gasification has been the technology by which I have built my business, and it's something which is really at the core of our energy balance in India. And it's good to see that over the years I've been attending this conference in Gasification India for I think more than a decade now, and the amount of understanding of what is happening on the ground is increasing much more. I mean, I was seeing Balyan sir's presentation. It is more realistic than what it used to be many years ago. I think Sharmaji will record few years ago, the presentations used to be really theoretical. Yeah. Right now we are moving towards what can be really done. Okay, so so what are we? The presentation will be in two parts. In the first few minutes, I'll just tell you what we are doing, and then for the CTL, I'll tell you what our vision is and how India should approach CTL, and what are the gaps currently all the decision makers are facing. And today, thanks to Dr. Saab, we are here, and two of the people I wanted to put my views are on the dais, right? So let's move on. So who are we? We are a gasification technology EPC company. We have focused for last 18 years on coal to heat, only for furnaces. And we have more than 180 operating gasifier systems. And Balyan sir, I think the total amount of producer gas between me and the other competitors is around 600. So the list 305 is very, very less. There's more than 600 to 700 operating gasifiers in India. I can share my list with you. So what is the technology we perfected? It is fixed bed, air, normal pressure, updraft gasifiers. And the key point here is that it has happened in partnership with a Chinese company called Yixing. Now, this is an important thing to understand, that if we want to do gasification, then China and the Chinese technology providers are the key in that game. And if we all ignore that, and none of them are here to talk, then I think the CTL dream is also very, very far away. Because all the pilot projects which sir mentioned in his presentation, BHEL, Thermax, CSR, all of them have not been able to really crack the problem. They all have some realistic problems with the ash, and the Chinese have more than 200 running systems among 3 license providers, which are stable and producing various end products. So that's where we have to focus. Now, these are some of our achievements over the last 18 years. We have done many first plants. One of them is at JSPL. The other is at very leading tile brand Kejaria, some of the iron ore pellet plants. What is the technology for fuel gasifiers? This is a double stage technology. We take the VM out separately. We take the carbonized gas separately. These gases are then processed through a multi-stage cleaning, cooling system to produce a gas which is almost equivalent to natural gas. Only difference is that because we are doing air gasification, it has 50% nitrogen, right? For all the cleanliness purposes, the gas is almost equal to natural gas, and almost every product furnace can be fired. These are some of the plants which have been running. These are both the pellet plants, iron ore pellet plants, being fired by our gasifiers. These are even glass. This is Hindustan Glass. The plant is running on, this is almost the world's first glass kiln on gasifier. Why is it important? Is because the temperature required is 1600 degrees Celsius in the kiln. Steel, this is a reheating furnace in Jindal Steel and Power. Ceramics, these plants are important because of cleanliness. The tiles require absolutely clean gas. If you have any carryover of tar, dust or sulfur, the product will get spoiled. So these plants has improved the level of cleanliness which can be brought out in the gas. So this is where we are today. In the fuel gasifiers, we have perfected the systems and the operations for last so many years. But what are the challenges which this current technology is facing. One fixed bed gasifier needs only sized coal. And if you size the coal, almost 60% of -15 is not usable, right? Second, all fixed bed gasifiers use hard and high ash fusion temperature coals, which are not abundantly available. Most of the abundant coals in India are with lower ash fusion temperatures and are not very hard. They are in between. Then the fixed bed gasifiers, atmospheric gasifiers, have a limitation of physical size, and therefore one system can produce maximum around 10,000 meter cube of gas. And if a user needs, let's say, 200,000 meter cube of gas, then you need 20 units. And it becomes cumbersome to plan. Land is a problem. This is what we are facing with the current 4 million ton pellet plants across Odisha, including JSPL. Many of these plants need 20, 30, 40 gasifiers, and there is no land to put them. Then low carbon conversion. Even if the most efficient plant, we can target maximum around 81, 82% of energy conversion from coal, and the system losses are in the range of 17, 18%. Then the gas is leaner because of nitrogen. Now, all these points, we have two ways. One is research, which we put up our own plants, pilot plants, then we do a small scale, then commercial scale, or we keep our egos aside and look at what is happening in the world. So the circulating fluidized bed gasifiers are operating from many, many years in China, stable, fully successful. So these gasifiers, why are they future for us? One, they can use coal fines. Second, there is no licensing fee or technology fees. They are just open, so there is no overriding charges of any technology provider. For fuel, we can use atmospheric pressure, and there is no fluidized ash. So they are operating at temperatures where the ash is not fluidized like an entrail bed, and therefore the cost of gasifier, refractory, everything is very reasonable. And we can have a large 6-meter gasifier which produces 40,000 meter cube of gas. So in terms of investment, sir, these are 1/5 average versus any entrail bed technology or a fixed bed high pressure technology. For fuel, these are the most economic and viable solutions for India. This is the general flow chart for what the CFB looks like. It's one circulating fluidized bed and then simple stages of gas cleaning, which produces a fuel gas which can be used to heat. They are running plants. There is no research required. You can go see. There are almost 45 such alumina GFC kilns which are running on these gasifiers. This is one of the example, and this is stable from last 7 years, 24/7, 365. This is a configuration of 2 running, 1 standby gasifier, and they operate 24/7. Now, when we talk of CTL, this is the heart of my presentation, this slide. What I wish to explain here is why CFB is the future for India, and why all the other technologies, including what we are currently doing in Talcher, is something which India should refrain from. Now, I have divided the whole process from coal, air to products into 4 different blocks to explain what has no proprietary knowledge and what is readily available. Okay, so now the coal preparation, air separation unit, slag, tar handling, all this is readily available. You don't need any high-end technology providers to tell you what this is. There are at least 25 engineering companies which among the dais people we can name right now who can do all this, right? Then we skip gasifier, this yellow part, we straight away jump to the next box. In this box, what we are doing is we are cleaning the gas, okay, removing whatever S2S is there. then we are shifting CO to H2 depending on what ratio of H2 to CO is required. Okay, and as you said, sir, the membrane technologies, most of them are non-catalytic. Absolutely no proprietary catalysts are used, and it is a play of pressure and membranes by which this is happening. Not any high-end technology which was used in Angul, sir. Okay, and then synthesis also. We don't need to go to 60 bar for synthesis. There are plants running at 15 bar. There are plants running at, okay, the vessel size is increased. Now what the Chinese technology providers are saying is that if you operate at low pressure, there's no problem with land and steel vessel being larger. Okay, so the only reason why the existing leaders in the market in the Western world are saying we should have small vessels is because of vessel size. They say we cannot transport a large vessel. Okay, we'll fabricate at site. I mean, that's the Indian thought process. You know, we have to put jugaad and innovation to make these things look viable, right? So this whole block, I think, gentlemen on the dais will agree, this is no rocket science. Now, the balance of plant, utilities, power, offsite facilities, everything, there is no rocket science. Okay, so when we can do 85% of the total capex without involving any super licensee or somebody who is asking for hundreds of $1 million only to give technology, we are only restricted to what kind of gasification. Okay, and in gasification, it is easiest that we all get together and we talk to all the leading Chinese plants which are running, and we all joined hands, and 20 of us, like the steel companies happened, sir, rolling mills did in the early 2000s, 20 of us fly there together and tell them this is what we want. We see all the plants, and whatever is the most viable CFB technologies, we import, and then we learn from it, and then we develop it, sir. So this is what is the way forward. Now, if you are doing, sir, the biggest mistake Coal India is doing the whole thing as BOO. When you do the whole thing as BOO, then the person will quote an obnoxious number which is absolutely unviable. And then they will go and ask for multiple levels of subsidies and everything. I have built my gasification business on economic viability. I have 180 plants which paid back through their own savings versus coal. So even for CTL, we have to look for things which are viable. And why I have written DRI, sir, here is because for even DRI clean operators, we need to sit with them and say, why hydrogen so high? Can we not increase the vessel size and reduce the metallization rate and use maybe 1.2, maybe 1.1 H2 to CO ratios? So all this need pressure and working from the senior most players of the industry. We are instruments as Dev Energy and even some of my competitors. We are service providers. We will follow your lead, sir. Wherever you take us, we will open the gates for you. But you are the investors, you are the people leading from the front, right? So this is my submission, and I think this, if as a joint effort we do, I think we can crack this code. So this is just what I've summarized in slides, why this technology is the way forward. And no experiments, sir. That's my point. We are not a country we can experiment with billions of dollars. We need to go on a path which is straightforward and implementable. Right? These are some of the factors which I wish to put forward what this forum can do. Sir, the second point is what I want to highlight, is that we don't put up a plant, but at least we can put $1 million aside and do a complete detailed DPR, up to an equipment level analysis, up to weights, definitions, pipes, walls, everything, so that we know. And we are not dependent. In our laziness, we are going for models like BOO and BOOT, because we don't want to know what is inside that black box, right? So this is my submission, sir. Thank you, and I'm available for any questions.